Hello everyone, this is Adhish. I'm a grade 10 student from Mumbai. Today's problem is the Crofts game. The difficulty level of this problem is medium, and you need to know greedy game theory, which is basically implemented in this problem through sorting an array in order to understand the solution. So in this problem we are basically given two arrays of n integers each, a and b, and during each turn a player chooses either AI or BI. So there are two players. So if Lara goes first, she will choose AI, and the second player, who Jonna, will choose BI at each time. And we need to find a way in which we order these n indices so that the players are always playing optimally. So each time the player will obviously play optimally and choose an integer I which is already not taken. And if the player is Lara, she will receive AI points, otherwise Jonah will receive BI points, and Lara goes first. So basically we need to find out which player wins if both of them are going to play optimally. So for example, let's say that we have 1 3 4 and 5 3 1. Then let's say that so this is the array L, because the first array will give us about Lara, and the second array, let's say it's J, because that will give us about Jonah. So in this case, let's say that Lara chooses to take index 4 because like that seems to be optimal, but let's see if it is optimal or not. So let's say L takes 4, then J will take 5, and then L is forced to take 3. So in that case, L will win, and you can verify that L wins. Another way is in which L chooses, let's say, 3, then J will take 5, and L will take 4, and in this way also L will win. And the third option is L takes 1, and in that case J can't take 5, so it's good. And then J takes 3 and L takes 4. So in this case also L wins. Now you can verify that in the second case, since all the elements are basically equal, it will be a tie and n is 2. So either ways L will take 1 and J will take 1. So in both the cases, both players will get score of 1. And in the third case, since like these numbers are smaller than these numbers, so 2 is less than 3 and even 2 is less than 3 in all possible pairs. That's why the second player, which is Jonah, will always win. Now, a possible approach to solve this problem is to think about a state variable which we will use to determine who to determine a particular quantity instead of just who wins. One possibility is in which we store the state variable to be, so we always need to work with state variables. So a tip on these kind of game theory problems is always work with state variables which capture the current state of the game, of the two-player game, and which will basically help us uh, to determine who wins, which will help us determine who wins or by what difference they win. So in this problem, we can actually find out who wins, or we can find out what is the difference in the scores. So that's one clue. So let's say that the state variable is the score of L so far and the score of J so far. Then and let's say we know or let's consider a simpler state variable, because we don't want to be storing the score of L and the score of J. So let's consider the state variable as the difference between the score of L and the score of J. So let's define the state variable to be L minus J. And now it's clear that if L minus J is greater than 0, then the first player wins, which is because Lara wins. If L minus J is equal to 0, this means it's going to be a tie. And if L minus J is less than 0, this means that the second player wins. Now we need to determine how the players are going to play in order to, and how will the state variable basically change. So in each moment, in each in each of Lara's moves. So in each of Lara's moves, she will try to increase her score because she wants L to go up, and hence the difference between L and J will increase. And similarly, in each of Jonah's moves, he'll try to increase his score. That's why the difference will decrease because they are doing minus J. So if J increases, the difference decreases. Now, what is the net result of these two operations? So how can we effectively capture what is happening? So the net result is that in each player's turns, the player will try to both increase the score and decrease the other person's score. And this means that, so let's say we consider a case when there are just two indices. Let's just consider two indices. Let's say L is 5 and L is 12, for example, and J is 15 and J is also, let's say, 2, for example. Then in this case, let's say it's Lara's turn. So in this case, which uh, choice will Lara choose? Which of the two indices will Lara choose in order to maximize L minus J? So in this case, let's say that Lara chooses 5, or let's say that Lara chooses 12 because that looks bigger. In that case, you'll actually realize that if Lara chooses 12, then J will actually choose 15. So this will mean that L minus J is equal to minus 3. However, if Lara chooses 5 and Jonah chooses 2, then this means that Lara minus J will be 3. So in this case, it's actually optimal for Lara to choose 5 rather than to choose 12. And why does this happen? The reason why this happens is because Lara is basically trying to maximize this value and also trying to minimize, or basically is trying to maximize this value and is also trying to maximize this value in order to ensure that Jonah does not choose this number. So essentially when she's taking 5, she's ensuring that Jonah does not choose 15, and hence his score is implicitly getting decreased. It's not explicitly getting decreased. It's basically basically because J cannot choose 15, that's why it's getting decreased. And hence the net result is that 5 plus 15 is greater than 12 plus 2, and therefore we choose to take 5 instead of 12. Now this can be applied in general. So in general we'll just take indices with the AI plus BI or LI plus GI larger. So take indices with larger AI plus BI values first, because when any player moves, he or she will try to increase their respective score, and they'll try to decrease the score that the other person takes, and they are implicitly decreasing the other person's score by ensuring that that person does not take this large value of AI or the large value of BI. So in both cases it's optimal to go for the index which has a large AI and the large BI, because that will increase both your score and that will prevent your opponent from taking a large score. And that's why we can just sort by AI plus BI in decreasing order. So therefore we just sort the array by AI plus BI values in decreasing order, and then we can just simulate this game. So we can maintain a boolean variable turn which represents whose turn it is, and if it's Lara's turn, we'll increase the difference by Li, and if it's Jonah's turn, we'll decrease the difference by Gi. And in the end, if the difference is greater than 0, we'll print first. If it's 0, we'll print I, otherwise we'll print second. So in the code, for each test case, I taken the value of n. I store 3 values in the vector. The first value is Li, so the index I, so sums I 0 corresponds to Li, or basically AI. Sums I1, I2 I mean, corresponds to Jonah, which is BI. and sums I0 represents Li plus Gi. So that's why we'll first take in Li, which is basically A or Li. Then in the second loop, we'll take in B or Jonah of I. And in the third loop, we'll set, uh, so we are sorting by AI plus BI in decreasing order. That's why we take the first value to be sums I0 to be sums I1 plus sums I2. And then we just sort in decreasing order or by AI plus BI to ensure that the both the values are increased. And then we'll take the turn to be 1. So initially it's Lara's turn. So if turn is 1, Boolean variable turn is 1 or it's true, then it will be Lara's turn, otherwise it will be Jonah's turn. And the difference represents the difference in the scores. And in the end, we know if depending on the difference, the player who has a difference greater than 0, if the difference is greater than 0, the first player wins. So in the end, if diff is greater than 0, the first player wins. If diff is equal to 0, it's a tie, and if diff is less than 0, it's the second player who wins. And now in the main part of the code, if the current player, so if turn is equal to true, then it's Lara's turn, and we'll increase the difference by sums I1 because sums I1 represents AI. If it's Jonah's turn, which is represented by by turn being false, then we'll decrease the difference by JI, and we'll set, so we'll basically reverse the turn, because if it was Lara's turn, then it will become Jonah's, and if it was Jonah's, it will become Lara's. And in the end, we print these three values depending on which condition is satisfied. And now I'll just submit this code to see that it gets accepted. So as you could see, my code got accepted. I hope you like this problem and my solution for this problem. If you had any doubts, do leave them in the comments down below. And if you like this video, don't forget to give it a thumbs up.